Hello, everyone. Today we are going to uh, do another review. This is actually reviewing circles. So the aspect that we're going to start out with the circles is inscribed angle and central angles and their relationship. So here we have inscribed angle because the vertex is on the circle, and that inscribed angle is going to be 29 degrees. And then the central angle is going to be here when the vertex is at the center of the circle. And so it says circle S, and so we know the center of the circle is going to be S because that's how we name our circles, by the center. So the center, the circle is the angle QTR, and the angle is really always going to be the letter in the middle. So if you look here, it says QTR is really just this angle T, which is an inscribed angle. And you know that's an inscribed angle again because the vertex is going to be on the circle. And this is asking what is the measurement of angle QRS. So basically, they want the measurement of this angle right here. All right, so in order to get the measurement of this angle, we need to find out what the central angle is. And so let's look at that work on the next page. So here, if you look here, I'm trying to cover some of this up because I don't want it to be so convoluted. So here you have, this is basically the same picture, but we're going to focus in on this triangle right here. Now this goes from the center of the circle to the circle, so I know that this segment right here, QS and RS, is going to be the radius of the circle. So this is a radius and this is a radius. So that means that this is going to create an isosceles triangle because this here is the radius and the radius. And so since these two sides are equal, that means that these two angles are going to be equal. Well, if I have the inscribed angle, it intersects the arc QR, and then I have the central angle, it intersects the arc QR2. That's this arc right here. Now, so if we have this relationship, the central angle is equal to 2 times the inscribed angle. So in this particular case, the inscribed angle is 29 degrees. The central angle is 58 degrees because if I multiply 2 times 29, I'm going to get 58. So I'll just take the central angle and the inscribed angle and double it, and that will give me my central angle. So this angle here is going to be 58. And so now I have this triangle, and when you add up all the interior angles of a triangle, they should equal 180. So I get 58 plus x plus x. So that's just going to give me 58 plus 2x. And now I need to find the value of x. And so the value of x is going to be 61 because you see here I subtract 58 from both sides. And that's going to give me 2x is equal to 22. But then when I divide both sides by 2, it's going to give me x is equal to 61. So this angle that we were looking for, QRS, is going to be equal to 61 degrees. All right, so let's look at another example. Now, this example here is going to be finding the area of a sector. So a sector is just going to be like if you're cutting taking a piece of, think of this whole circle as a pie. And if I want to as a complete pie, and then the sector is just going to be a slice of the pie. So how do we find the area of a sector? This is going to be theta times pi r squared over 360. Your theta is going to be your central angle. R is your radius. And then we're going to use the approximation 3.14 for pi. And so we just want to find the area of this sector. We can see that the central angle in this case is going to be 50. So our theta is going to equal 50. our radius is going to be 2 centimeters. And so now we're just going to plug everything in. So we're going to get the area of the sector is going to be 50 times 3.14, which is representing our pi, and 2 to the second power, or 2 squared, divided by 360. And you can go ahead and put that in your calculator, because that's what I did. And I got this is equal to 1.74. This is actually centimeters squared. And this is, I got 1.74 repeating, so that's why I put the little bar up here. All right, so I don't think that'll be too difficult. This is review, so hopefully you do have a lot of notes already on this, but yes. So let's go on to another example. And in this example, we're going to be looking at using tangent lines to determine things about the circle. So in this particular case, we have a circle A. So we know the center of the circle is A, has a radius of 8 centimeters. So remember, if the line segments that start at the center and touch the circle is going to be the radius. So that means AD is the radius of the circle, but that means AB is also a radius. So we know that this is going to be 8 centimeters as well. And it says segment DC and BC, they're tangent lines. So these two lines here are tangent lines. Now the tangent line, a line tangent to a circle and the radius, if they intersect, they're going to create right angles. So these are right angles. And at any time, you can stop, pause the video, and write some of these things down, because I did not write that the tangent line, the line tangent to a circle, when it intersects the radius, it intersects at a right angle. So that is something that you should write down. So the question is saying if AC is equal to 17 centimeters, so this is AC here. So this distance here is going to be 17. And we know this distance AB is going to be 8. They want to know this distance BC. So I went ahead and wrote that over here on the side, because I could just extract this. And this is just a right triangle. This length here is 8. This length here, this is my AC 17, and I want to find X. So this is kind of what we did last week. It's just a Pythagorean theorem. And so I know that 8 squared plus X squared is equal to 17. I can subtract 8 squared from both sides. That gives me X squared is equal to 17 squared minus 8 squared. And then to get rid of the squared, I'll just take the square root of both sides. So you can see that better here. I know that BC, which is also X, is equal to the square root of 17 squared minus 8 squared. And once you put that into your calculator, you're going to get this is equal to 15 centimeters. So this value from B to C is going to be 15 centimeters. One thing that I want to point out to you, what really makes this problem works well is understanding that the tangent line and the radius, when they intersect, they create a right angle. So that's really the big thing in this particular problem. All right, and let's go to our last example. The last example is going to be over secant lines to a circle. So a secant line is going to intersect the circle at 2 places. So you can see the secant line is intersecting the circle here at point F and point G. And then this is a secant line because it intersects at D and C. So we have this relationship when we have secant lines. We have part times whole is equal to part times whole. And I call it part 1. It doesn't matter which one you choose for part 1. So you can see here EF, I'm going to use that as part 1. So from the distance from E to F is 3 centimeters. And then I'm not going to put anything, but I don't know right now what FG is, but we'll see later what FG is. So from F to G, that is going to be, I'm sorry, not from F to G. So from E to G is going to be your whole, because we just only want to talk about parts and whole. So the part of this line is F, E, F, but the whole secant line is E, G. And then if you look here, you have the part is segment ED, and the whole is EC. So we want to, the question tells us what? It says EG is 12 centimeters. So that means the whole here, E to G is 12 centimeters. So that means F to G is going to be 9. And then this part, E to D, is going to be 4 centimeters. But the question asks us to find what is DC. So DC is just going to be this distance right here. So let's go ahead and call that X, because we don't know what that value is. But since from E to G is 12 centimeters, well, if this part is 3 centimeters, from E to F, that means from F to G, this has to be 9 centimeters. All right, so let's go ahead and plug it into the equation. So my part 1 is going to be 3 centimeters. That's E to F. So I got my 3 centimeters. And then my whole is going to be EG, which is 12 centimeters. So that's why I got 3 times 12. Now let's go down here. My part 2 is going to be 4 centimeters. So that's why I got my 4 here. But to get my whole, I'm going to have to do what? 4 plus X. So my whole, it should have a 2 here. I'm sorry. That should be a 2. And my whole here should be, my whole part for my whole 2 should be 4 plus X. And so now we have a simple equation that we can simply go ahead and solve for X. So 3 times 12 is going to give us 36. Now I need to distribute my 4. So 4 times 4 is going to be 16. Then I have 4 times X. So that's going to give me my 4X. And now I need to get X by itself. So I'm going to subtract 16 from both sides. So that's 36 minus 16 is going to give me 20. And then now I can cancel out the 16s here and bring down my 4X. So I have 20 is equal to 4X. And then to get X by itself, so I need to divide both sides by 4. So X is equal to 5. So my distance from D to C is just going to be 5, and I'm done. So if you have watched the videos in the past, you will see that the problems that I am giving you for the quiz is exactly like these. So they are pretty straightforward. But please, if you do not understand something, make sure you email me, ask questions. Some of you guys have been sending me text messages. That's fine too. And some students have been confused on where the quizzes are located. If you go to assignments and you do not see the quizzes in assignments on the Canvas, then just click on the quizzes tab and they will pop up. Again, if you're having trouble with any of that, just send me an email and I'll be happy to assist you. All right, thank you guys. I hope all is well with you, and I guess, speak with you again on next week with our next video.